Hello everyone, welcome back to my channel. Today let's go over a medium level question that I just solved on my own. So I'm super happy about this and I'm very glad that I was able to come up with my own solution to this question without any help. So let's go over it and let me show you how I did it. This is 3639, minimum time to activate a string. So basically you're given this string S and an order array and an integer K. Basically, you want to know what is the earliest point. So this is earlier than this, the earliest index. So if we have 1, 0, 2, we're looking for the earliest index, right? Where up to that point, up to whatever point that is, the shorter it is, the better, right? Shorter it is, the better. Basically, if we make those changes inside of this, so for example this would be 1, so A star C for this chunk. If that's valid, meaning the number of substrings that have at least a star is greater than or equal to K, then that's a valid result, and we keep shrinking the search space, right? We want to find the shortest chunk where if you make those changes, those edits in order, then it's valid. So my approach to this was using a binary search, and so that's what I did. Again, we're trying to find the leftmost position in order where this is still valid. And we want to return that index, right? So let's set this to infinity because we're trying to minimize a value. And let's call this mid. So we're starting at the mid index, right? And then we're going to keep shrinking if it's still valid. So if this is valid, we're going to try this. If this is valid, we're going to try this, right? So if is valid of mid, then right equals mid minus 1, throwing away the other half because there's already a better answer, right? Why would we check this chunk if this chunk is already valid, right? So, and then at that point, answer is min of answer and mid. Otherwise, left equals mid plus 1 because it's not valid, so we have to throw away the left chunk. And yeah, so at the end, we can just return answer. But now we have to figure out how to define is valid. So this is the index, right? So let's say we're trying this chunk right here, 1, 0. So basically we're going to make all those differences, all those changes inside of S. This is going to turn into 1 being edited, and then which is going to turn into star star C, right? For this chunk. So let me put this right here so it's more clear. Cool. So that's what we get. And then we're going to see how many substrings are valid. If it's bigger than or equal to K, then that's already a potential answer. We don't need to check this chunk if this is valid, as I said. So now let's just call this a list because that's just going to be everything from order to mid plus 1 because we're including mid, right? If mid is index 1, we slice the array in half. We're binary search first tries the middle one, then this is going to be it. So now we're just going to say for n and now, let's call this copy. So copy is just going to be a list of S. So we're going to edit copy of n to be equal to this, right? And let's just print copy and cur for now. Let's just return false, give it a dummy value. Okay, so yeah, cool. So you can see if we're 1, 0, 1, these both are changed, although they're out of order. That's fine, but this is going to be for this. For 2, everything is included, right? So at this point, we are trying to find the number of substrings that has at least 1 star inside of it, right? So what that means is if we're checking this substring and we're checking this substring, if we're getting a star, then we know the rest of the substring has to have stars because we're always going from the left to right for substrings, right? So if this is a star, we don't even need to check this substring. What we just do is do the length minus this index because that is the number of substrings that are left, right? So that's kind of the key insight here that I came up with. So basically for I in range length copy, what we're going to do is get all the indexes of the stars, right? So for I, C, and enumerate copy, and you'll see this comes in handy because we're just going to append I. And then what's going to happen is because we have all these indexes, right? Let's print index. Let's go step by step here so you guys can understand how I did it. So this is already sorted because we're going from left to right, right? So now we're going to do, let's print I and index. The key insight is to run a binary search. If this is already what it is, or because we're going to bisect left inside of this list using this value, which is going to find the leftmost value that's equal to the current value. If that is, then we can just say the whole size of the array minus the current index, because that's how many subarrays are already valid. Because if this has a star in it, right, if this has a star in it, then we don't need to check the rest of the subarrays, as I said, right? So that's the key insight here. So we're going to run a binary search on index using I, and then we're going to say if BL is less than length of index, because if we're here, the way binary search works is, the bisect left works is if it doesn't find it, it might give like an out of bounds value. So if it's inbounds, then that's the leftmost value that has a star. Okay, so if index of BL is equal to a star, then we can just add, let's call this total, that's the number of substrings. We're going to add the length of copy minus BL, right? So then at the end, we can just return is total bigger than or equal to K, which is going to give us a number of subarrays. So that was my idea and my way of doing it. So let's go ahead and run this. Okay, that's not correct. So yeah, we want to return answer. We might want to do, well, let's see here. So nope, something is a bit wrong here. So in this case, then that's how many subarrays are valid. So let's go ahead and print length of copy and BL. So let's call this here. If BL is less than length of index, and if this value, oh, we're supposed to bisect left finding this, right? What am I trying to do here? So again, trying to find that value. And if we find that bisect left value, let's call this value is index BL. Let's print value. Yeah, so if copy of value, sorry, because this is the index, sorry, so I got that mixed up a little bit. If the copy of value is equal to a star, because it's a reflection of exactly what this is. So for example, if the star is this, then our list would just look like 0 and 1, right? So if we're on 0, we're checking the first subarray. We're going to say this is already a subarray that has a star, so we're not going to check the whole thing. We're going to take 3 minus 1, right? So let's run this. Copy. Let's run this. Okay, submit it. Okay, and if answer never changes, then we just return -1. Okay, so yeah, that's basically the gist of this. Instead of making this a double loop and finding n squared, this is my optimization. So yeah, and then if it's valid, we're going to keep shrinking. Unless it's not valid, then we're going to keep throwing away the left half to find a point where it is valid. Okay, so we're going to run this again. Submit it. Okay, so still something is a bit wrong here. Let's see if total bigger than or equal to K. We might need there might be some edge cases here with the bisect. So we might need to do a +1. Okay, yeah, +1 because yeah, that's the edge case. So if this is valid, because everything else from the right is going to have 1, then there's going to be 1, 2, 3 subarrays, not 3 minus 1. 3 minus 1 plus 1, right? 3 minus 1 plus 1. Because 1, 2, 3 subarrays, as long as there is a star here, then everything to the right is going to be valid too. Okay, so let's run this, submit it. Oh, okay, so, that's odd. Yeah, we're taking to the mid, and then oh, if C is equal to a star. I don't know why I left that part out. I was looking at this. I'm wondering. Yeah, I can't believe I forgot about that. Either way, let's run this. No, it's still wrong. Okay. Um. Hmm. Let's see. Let's see. Let's just do this the other way. I just want to try something. So for j in range, I length of copy. Let's create a counter. So this is the dumb way of doing it. C of copy of j. So if star is in C, then total plus equals to 1. Okay, yeah, it is my binary search that's a bit messed up here. This is not going to pass because that was slow. That was what I tried first. And okay, so what this tells us is we can run a binary search index I. And then if BL is less than length of copy, and if copy of BL is equal to star, then we can add length of copy minus BL plus 1. That's what it's supposed to be. Not really sure why that's incorrect. So let's do this. Okay, let's just print copy and index. Is there one? Maybe we want to do this. 0, 1, 2. 0 and 2, yeah, that's correct. BL is less than length of copy. The value is value is index of BL. So if copy of value, nope. This is a bit tricky. Okay, so yeah, there has to be something there because that's the only way. Let's print index I, index, and BL. So I index and BL, yep. So yeah, we have to find the insertion point. Yeah, it's weird. Anything that's bigger than it, 0, 1. Oh, yeah, anything that's bigger than or equal to the current. This is going to be, so let's print value. Okay, I was subtracting the wrong thing. It's minus value because that is the actual position that has something. Pretty sure. Let's submit this. Okay, so let's print index and value. Oh, no, because it is the right place, index of BL, so we have this value, it's minus I plus 1, right? No? I swear I just had this. Let's see, index value. So, yep. So, let's print I as well. Yeah, so 2, because we can't use 0. 2 is 2. Length of copy minus I, maybe? No. So let's try to debug this again. Yep. 2. And let's print length of copy. So if it's 0, for example, the first for the subarray is supposed to be this minus this. Just trying to find how many subarrays there are. So, yeah, because it includes I. Maybe it's index. Let's see. So minus BL plus 1. I think we just had that. So trying to loop through here and find something. Is it length of index? Oh, okay. Let's run this. No. Hang, this is... So, if copy of val... You know what? Let's just print index and BL first. Let's get this out of the way. Yeah, so that's what it's supposed to be. Index 0. Let's print I. Yep, that's right. So in that case, if BL is less than length of index, then let's print index value. Value is just index of BL, right? So, and then Right, so if that's the point that we already have the substrings in just 1, 2, 3 substrings. Plus equals to length of copy minus BL plus 1. That's supposed to be what it's supposed to be. No? Length of copy, length of index. It's a sense where it's supposed to be, because anything to the right of it, but it's not, because the current also counts. Bisect left, value is index of BL. Well, we already know those are strings. Is it I though? Confused. Literally just looking for this. J in range, I length of copy. If what I want to do is copy of J is equal to a star, then just total plus equals to length of copy minus J plus 1, and then break. That's literally it. Wait, what? Copy of J. Yeah. So if it's equal to a star, then because that means that all these are also included. Why is this wrong? 1. So length of copy is 3 minus 1. Or is it this? Okay. Oh, it might just be length of copy minus J. Yeah, these edge cases are nasty. Okay. Let's see, at least this times out. Okay, cool. At least it's timing out now. So now we can go back to doing this. Index of I. So I guess if copy of I is equal to a star, then we can do this, because I'm thinking that's the only way we have that. And then we can say total plus equals, because we already know whatever we find in index, as long as it's in bounds, then we can just plus equals to length of copy minus BL, right? That's what I think. Let's run this. Oh, okay. Let's submit it. What? If what the heck? This is really weird. Is this the problem? No, that's obviously not the problem. If this is index.append I, yeah. Oh, we don't care about if it's I or not, right? Or we do? Yeah, I just want for everything to the right. What is the soonest? Yeah, so bisect left inside of index I. The soonest including I, right? If BL is less than length of index, value is index of BL. Let's print value and index. It's embarrassing, because I just did this question literally by myself a couple minutes ago. Okay, 2. So then we can just say total plus equals to length of copy minus val. Okay. Oh, okay, cool. Yeah, that was what it was. Okay, cool. So yeah, that was a tough one, but either way, yep, that's it for this video. And again, I'm super glad that I was able to come up with my own solution to this question without any assistance and solve it completely on my own, even though it was a little bit of a struggle. So yeah, again, that's it for this video. Thank you for watching and stay tuned for more.